Great. So I think that should be working. Yes, perfect. First of all, thank you very much to the World Petroleum Technology Congress for the invitation to be here. I am thrilled to be in India for the first time and to participate of this event and to have the opportunity to showcase some of the work that we are developing from the Fraunhofer IPA side in Germany. Today I will not be particularly addressing the issue of hydrogen transportation, as Dr. Pandyopadhyay expressed some minutes ago, but rather an alternative way of producing hydrogen that we are working on. Just very quickly, I know we are a bit short on time, a short glimpse into what the Fraunhofer Institute does, what we are working on, and some data. So the Fraunhofer Gesellschaft, so the whole society of the Fraunhofer, is one of the world's leading applied research institutes worldwide. We have several offices in Germany and some also scattered around the world, as for example is the case of our Indian office. Particularly the Fraunhofer IPA, so the Institute for Manufacturing, Engineering and Automation. We are active in several fields where we work mainly in the process of technology development and optimization, but as you can see, we are active in all of these areas. And particularly the group I belong to belongs a little bit on the side of the process industry and the energy, and this is the group Sustainable Development of Biointelligent Technologies. And we work with this concept of the integration of biology into technology. This was born from the idea or from the realization of this trend that technology is becoming more and more of the biologicalization of technology, if you wish to say it like this. The trend basically describes the integration of biology into technology at different levels. So at some level you have, for example, the biomimics, where we try to emulate nature in its processes to make processes more efficient. But at another level, you also have the integration of biological components into technology, which is goes more related into what I will be presenting today. So this covers, for example, aspects as the efficient use of bioresources, including biomass, and is therefore the topic for my presentation today on the production of biohydrogen. So I think today we have all heard quite often why hydrogen is needed, why is there such a big interest on producing hydrogen sustainably, even at the European level. Recently with the development of the European Green Deal, so there was a big push for hydrogen for industry. And the message is clear: we need sustainable sources of energy, and hydrogen can help us achieve this, at least to some extent. Of course, there is no one-size-fits-all solution, but hydrogen can certainly make a contribution in this area. I will just skip quickly through the slides. On the other hand, we have also heard from the International Energy Agency that an effective use of biomass is necessary to achieve net zero emissions by 2050, along with implementation of technologies such as carbon capture and storage. So, moreover, they also specify that we need to transition from a traditional use of bioenergy, meaning basically the burning of biomass for cooking, for example, or for heating directly, and we need to go towards what is called a modern use of bioenergy. So a sustainable and efficient use of the biomass in an industry setting and with high efficiency. So combining this idea, we developed a concept we call hydrogen bioenergy with carbon capture and storage. And this concept is what we've been working on the last couple of years. It's quite recent idea. And I will be telling you a little bit more of the projects we have in this area, but basically what this idea proposes, or the main topic, the main goal, is to use biomass, and this is quite general, to produce bioenergy through different methods, either biological or thermochemical. So we are looking into different technologies, either fermentation methods, anaerobic digestion, but also technologies like gas reformation or water gas shift reactions, gasification. And the idea is that when you combine this with carbon capture, that you can separate the hydrogen and use it effectively as an energy carrier or directly in chemical synthesis. You can also obtain a high purity of carbon that can also be used as a product in itself. This is a brief an overview of the areas we are looking into. So we are focusing mainly on the use of organic waste and residues, a lot of lignocellulosic materials. And as mentioned, we look into different approaches to producing hydrogen and carbon dioxide. So we are looking, for example, into technologies such as dark fermentation, along with some partners, what is called dark photosynthesis, gasification, direct gasification combined with steam methane reforming, and all this combined with carbon capture, either also through some biological methods such as algae cultivation for further synthesis of chemicals, or direct carbon capture. The carbon resulting from these approaches, I think has also been mentioned earlier today, can be used directly in chemical industry, for the agriculture sector in greenhouses, for example, or for the production of synthetic biofuels. These are some examples of projects that we are currently working on, where we are developing pilot plants. One of them, Smart Bio H2. This is to be implemented at a chemicals plant from the company Evonik in Germany. So they are producers of bulk and fine chemicals. And the idea, the concept uses two biological processes that result in the production of biohydrogen by using waste streams from this chemical plant and lignocellulosic material. In this way, it is expected that we can valorize these waste streams and also supply the hydrogen that is needed in further synthesis reactions at the site. In another project, H2 Wood, we are looking at a similar technology, but we are considering waste wood as substrate for also a biological reaction, but we are comparing it to a gasification step whereby steam methane reforming is applied also for producing more hydrogen along with water gas shift. So we are considering different combinations. This I will just briefly skip. I think I already covered the main aspects of these projects, and what we're looking into is to expand this idea to, our focus is mostly on decentralized technologies that can be operated easy to operate, decentralized, and that can use a wide variety of substrates, especially lignocellulosic substrates. So we are looking for opportunities, so I would be happy if you could contact. If you have some suggestions, ideas, or cooperation ideas, please feel free to scan my contact details through the QR, and yeah, let's get in touch. Thank you very much.